Okay, so I came to do question 8, and first off the top, I realized there was a mistake with the electrons because I wrote out my full half equation, came to the end, and just put 4 electrons in there. However, as we're going to discover, this cathode half equation needs to be times by 5 and then combined with just the anode reaction as is. Therefore, the anode reaction has to have 20 electrons, and that does track with oxidation numbers. I just went through it too quickly and missed that little bit. So, first thing we're going to do, we have to calculate the half equation for the anode reaction for a propane fuel cell. So, again, oxygen is going to be reduced at the cathode. Our fuel, propane, is going to be oxidized at the anode. A good place to start is actually writing the overall equation for the fuel cell. Because, if we think of it, when we have these hydrocarbon fuel cells like methane, like propane, what's actually happening overall is a combustion reaction. So what we're going to have is we're going to have propane plus oxygen gas, and I'm going to just say right now, I'm not going to put states in because it makes it easier to write, but make sure you're of course putting states in. Propane, oxygen gas producing CO2 and water as gas. So, balancing my overall equation for the fuel cell, I've got 3 carbon, 3 carbon, I've got 8 hydrogen, I've got 2 here, I need 4, and then how many oxygen does that leave me? I've got 6 here, I've got 4 here, so it must be 10 total, so 5 lots of O2. This is my overall equation for the fuel cell, and that leads me to write a half equation for the anode reaction with my propane. So again, I have C3H8, and I know it's going to produce, for sure, CO2, because where else is that carbon coming from? Again, I'm not putting my states in. You must include states. I'm sure you know what they are, gas, gas, and so forth. So, I've got my propane. I'm producing 3 carbon dioxide. What I need to do now is I need to balance first for acidic conditions, and then I need to add those hydroxyl groups to make it alkaline conditions, because that's what the cathode half equation is telling us. So I have 6 oxygen on this side. I need to have 6 on this side. So I've got 6 water. Then, back over here, I need to balance for my hydrogens because we're doing it first for acidic. So I have 12 plus 8. I've got 20 H plus. Okay, brilliant. So I have, at this point, not put my electrons in, but I've balanced for acidic conditions. Now we do what we've talked about before, and we add hydroxyl groups to balance for basic conditions. So if I've got 20 hydrogens here and I need to get rid of them, I'm going to add 20 hydroxyl groups, and this will produce my water here. You have to add the same thing on either side. So again, I've got 20 hydroxyl groups here. This is my first step in balancing for alkaline conditions. All I need to do now is take this and go, okay, this is going to be 20 H2O. So we've got 20 lots of that. And then over here, I've got 6 H2O. So again, that's going to knock out that 20 for me, and that's going to make that into 14. So I've got 14 H2O here. I've got this cancelling out here. I'm left with C3H8 plus 20 hydroxyl produces 3 carbon dioxide plus 14 water. Now, at this point, I just added in 4 electrons and I was like, yeah, that checks out. But really, it doesn't. Because if you look at oxidation numbers, it doesn't work like that. Now, we have 8 positive hydrogen. This must mean that these 3 carbons are actually 8 negative to balance those hydrogen. The way it works, because of electronegativity, we won't go into it too much because you don't actually need to know, and I won't put propane in a SAC, and I haven't seen it in an exam, is that 2 of those carbons that have 3 hydrogen on them will then have 3 negative, 1 that has 2 hydrogen will be 2 negative. So overall, we've got negative 8 here, and we need to have, how many electrons? Well, we need to have 20, because we know that this is going to come into here just as is. It's just propane, there's no change in coefficients, so this will just be slotted right into our overall equation. This is going to be times 5. So we need to have 20 electrons, because there'll be times 5 electrons here, we need 20 electrons here. So looking at our carbon, its oxygen is 2 negative. So each CO2 molecule has positive 4 on the carbon. So 3 lots of positive 4 takes us to positive 12, which of course, from negative 8 to positive 12, that's a shift of 20, so it's 20 electrons lost, climbing 20 places in oxidation number. And that is the answer for 8A and B.